Okay, so this is my response for quiz 3. He gives this diagram. It says that theta 1 is equal to 46 degrees, theta 2 is 22, and the tension in both cables are the same. He gives us the ball weighs 5 kilograms and the radius r is 1.6 meters. It also tells us that the ball is moving in a horizontal circle at a constant speed. So I went ahead and drew the free body diagram of just the ball. And with its forces, so we have T1, T2, and the mass gravity of the ball. Some forces in the y, we get T1 sine of 44, which is this beta angle that I found just doing 180 minus 90 minus the given angle of 46, plus T2 cosine of 22, taking the y component of this cable, is equal to mg. But earlier in the problem, it gives that T1 is equal to T2, so I just rewrote it as T times the sine of 44 plus the cosine of 22 is equal to mg, and found that our T is equal to 30.24 newtons. Then I went and sum forces in the x with the left being the positive direction. I have T1 cosine of 44 plus T2 sine of 22, taking both the x components, is equal to mass times acceleration because it's a horizontal circle. The acceleration is moving in a circle, so we can rewrite the acceleration as v squared over r, since it's going to experience a centripetal acceleration. We found earlier that where it was given that T1 is equal to T2, and we found our T to be 30.24, so I went ahead and plugged that in and rewrote as 30.24 times cosine of 44 plus sine of 22 is equal to the mass of the ball times the acceleration. And then I went ahead and just divided over the mass of the ball, which was given as 5 kilograms, and then multiplied it by the radius, which was given as 1.6 meters. And that gives us v squared is equal to 10.587. And when we take the square root of that, we get that our velocity is 3.25 meters per second.